Hello, I'm Tomáš Golembiovský. I'm a software developer in oVirt, and I will tell you a little bit about our plans for automatically dedicating CPUs. Usually when you create a VM, you don't care too much where it runs on which CPUs. All you configure is just some number of virtual CPUs, and that's it. Sometimes when you want to be a little bit more picky, you configure also a virtual topology in terms of sockets, cores, and threads. But there are situations where it really matters where your VM runs, and especially if your virtual topology matches your physical topology, because it can make your workload run much faster. A specific situation where that matters is NUMA, where you have a set of NUMA nodes. Each NUMA node has its set of CPUs, a dedicated memory controller, and a local memory. And when you want to access the memory of the NUMA node, it's fast. If you need to access memory from some other NUMA node, it takes time. So it really matters where your VM runs, and you want to stuff as much of the workload on a single NUMA node as possible. So let's say you do care where your VM runs. What options do you have in oVirt? One option is to manually write a pinning string. The language for that is pretty versatile, which makes it quite flexible, and you can define whatever you require. But it is also difficult to understand, and when it's difficult to understand, it's obviously also difficult to write. And also, for the pinning string to make sense, your hosts need to be of same or similar topology. Another option is the NUMA autopinning, which resizes your VM based on the host topology, and it uses our advices for sub-HANA users, which makes single core of each NUMA node unused. And despite the name, it's not so automatic as you may think. It takes effect not when you start the VM, but only when you close the edit dialog. So as you see, both methods have some limitations. It's either static or evaluated on the VM edit and not on VM start, so it doesn't take into account VMs already running on the hosts. They are limited to host that you pinned the VM to, and the CPUs dedicated to your VMs are not really dedicated, but are shared with other VMs. So you need to take care, and you probably don't want to run on the dedicated host any VMs that don't have CPU pinning. And our plan is to fix the situation somewhat by introducing a set of policies for automatically dedicating CPUs. The idea is that the CPUs will be pinned one-to-one, virtual topology to physical. The pinning will be adapted on each VM start, and the CPUs will be assigned exclusively, and so it won't be shared with other VMs running on the same host. And especially host pinning won't be necessary, and the VMs are supposed to be able to run on any host that satisfies the topology requirements of the VM. Initially, we plan to create 3 policies, one called simply dedicated with no special limitations. Other one is called isolate threads. It is for simulating environments without SMT. And the third one is sort of the opposite, which is for SMT environments, and it makes sure that your VMs run as effective there as possible. Before we proceed, let's make one thing crystal clear. The feature is not for security, but it's performance feature. And that's because even though the CPUs are dedicated exclusive to your VM, there may be brief moments where your VM runs on different CPUs, especially during boot or shortly after migration, or situations where other VMs may run on the CPUs dedicated to your VMs. While this doesn't create any performance penalty, it is probably better to not rely on the feature for security purposes. So let's say you start your VM with a dedicated policy. What happens? The first engine analyzes the resources available at that time, depending on what's running on all the hosts in the cluster. It tries to schedule the VM to start on the one host that best suits the topology requirements and the policy. When that happens, VDSM makes sure that there are no other VMs running on the dedicated CPUs and starts your VM. As I mentioned in the beginning, most of the time you don't really care where your VMs run. All you want is just some number of CPUs. So you obviously don't want to define the CPU policies for all VMs. This kind of VMs without any policy are using CPUs from shared pool, which is a dynamic CPU set that changes on every VM start. It is initially full and contains all the CPUs on the host, and when you start or stop VMs, it shrinks or grows. And one notable thing about it, shared pool, is that it is never empty. It contains at least one CPU where the VDSM process runs. So let's take an imaginary host with 4 cores and 2 threads per core, and it looks like this when you start it. Our first policy is called dedicated. It's the simplest of all 3, and it doesn't provide any other limitations despite the topology that you defined and the number of CPUs that you want. Let's have a look on some examples. Let's say you want to start the VM with 3 CPUs and you have a topology where you want 3 cores and 1 thread per core. Then you can end up with 2 scenarios. One situation is where your VM actually runs on 3 cores and it uses 1 thread on each core, and the other threads are used by other VMs. Or you can end up with a situation where it runs on 2 cores and only 1 thread is shared by other VMs. Different from it is a situation when you start a VM which requires 2 CPUs and you want 1 core with 2 threads. In this case, the topology requirement will be considered, and you will have only 1 core with 2 threads, and you cannot end up in a situation where you have 2 cores. The other policy is isolate threads, which does basically similar thing what the dedicated, but about that it makes sure that each virtual CPU is placed on a separate core, and especially it makes sure that no other VM uses threads on the dedicated cores. So it sort of emulates the architecture without any SMT. And it makes sure that your virtual CPUs are pinned to physical CPUs 1-to-1. What does it mean? So let's have a look again on the examples. For the situation of VM with 3 virtual CPUs, you will get 3 cores. For each core, you use only 1 thread. Because the virtual CPU is pinned to the thread, it is not possible for it to roam to the second thread of the core. And because whole cores are dedicated, no other VM will ever use the empty threads. If you look at a situation where for VM with 2 CPUs and 1 core with 2 threads, you'll notice that it will run on 2 cores, which is slightly in contradiction with the topology requirements. But then again, you require a policy that emulates host without SMT. So obviously this is not the best use case for this VM. And as I already mentioned, if you compare the isolated threads policy to the dedicated policy, you'll notice that the second threads on each core are blocked from other VMs for the other isolated threads, but for the dedicated policy, they can still be used by other VMs running on the host. Our last policy is called siblings. It requires host with SMT, and it makes sure that the core that you have allocated are used as fully as possible. And again, it makes sure that the cores allocated to you are not used by any other VM. So let's have a look at our examples again. For the case of the VM with 3 CPUs, we will end up with 2 cores and 1 thread on the second core will be unused. And for the VM with 2 CPUs, where you want 1 core and 2 threads, it will match exactly your topology requirements, and you will always have 1 core. Again, if you compare the situation for the VM with 3 threads, on the second core, you have only 1 thread in use, and the virtual CPU running there will not roam to the second thread, even though that thread is also allocated to your VM. And that's it. We expect this to work for all normal flows. For some flows, the CPU set of your VM may change during its lifetime. For other flows, it will stay fixed. Our UI for that is not yet decided. The configuration part is easy. You will be able to define the policy of your needs, and that's it. But you'll also most likely would also want to know which CPUs are used by your VMs, and also the host level view of the CPUs for all VMs running on the host. And for that, we are still deciding how to do that. All the work is planned for the oVirt 4.5. And if you have any questions, you can reach me or other developers on chat or other usual communication channels.